right, good morning. I apologize that I'm not here today, but what you're going to do today is you're going to learn a little bit more about the concept of conservation of energy. So yesterday we derived that equation for conservation of energy, and if I can I'm just going to open up one of these to show you the equation. So remember the equation for conservation of energy is this one. We said that if your total initial energy plus any non-conservative work you do is equal to your final energy. Right? Now we did some math with that yesterday. Today I want you to look at it conceptually. There's a worksheet that the sub has for you to complete today. And let me just show you something about that here. So when you get the worksheet, you'll find the Energy Skate Park PhET Lab, which is either in the agenda here today or it's also in the calendar out here. If you go to that, then there's a link here. You're going to turn this on, and then you're going to start with the Intro tab. You're going to turn on the pie chart, the bar graph. You can actually probably turn on all of these. And then you're going to just watch the skater and answer some questions about that. So I showed this to you a little bit in class yesterday, but you're going to get some questions about it. Now, the key that I want to point out to you is, right, you should see the idea of conservation of energy, that the total energy doesn't change. So if kinetic energy goes up, potential energy has to go down by the same amount. The other thing I want you to notice, though, is that how do you gain energy? You gain energy by doing non-conservative work. So in this case, if I were to lift the skater, what I'd be doing is I'd be applying a force across the distance, and that's what's causing the energy to increase. Right? And similarly, if I turn on friction, which you will do later on, so I can do positive non-conservative work to lift the skater up, and then friction can do negative non-conservative work to slow her down. This simulation kind of calls that work thermal energy. But another way to think about it is if you click this trash can, it shows that the amount of energy that you have is shrinking to indicate that friction, again, is doing negative non-conservative work. So I'm going to ask you to do that assignment, that worksheet that the sub has for you, and when you're finished, you can just scan a picture from your phone and upload it here just like you usually do for your homework. And then when you are finished, you've got your syllabus you can work on, and then you've got your peak final exam review packet. Again, remember there are substantial bonus associated with doing the extra things with that review packet. So the review packet will be due for everyone on final exam day, but if you decide to do some of those extra things, remember that there's quite a bit of bonus for that. All right.